Well, welcome back. Our topic tonight is arc trig integrals. So this should be very new to everybody today. So before we jump into the integrals, let's take a quick review of the arc trig derivatives. So the first derivative that we talked about was the derivative of arc sine. And I'm going to say arc sine of u. And hopefully you'll recall, you should have memorized by now, its derivative is du over the square root of 1 minus u squared. The second derivative you should be familiar with is the derivative of arctan. And again, instead of saying arc, you could say tan inverse or inverse sine. Those are all congruent. And this one is du over 1 plus u squared. So again, you should have these two derivatives committed to memory. So let's do two quick derivatives before we jump into the integrals. So let's go ahead and find the derivative of arc sine of 2x. So try it, pause it, try it on your own, and see if we get the same thing. So all you have to do is pick that u and take its derivative. So I'm going to say my u is the thing in parentheses, so 2x. Its derivative is just 2. And I'll just follow that rule. We just said arc sine was du over the square root of 1 minus u squared. So I've already said my du is 2 over the square root of 1 minus. And just be careful here, remember it's that quantity 2x squared. I'm going to clean that up one more time and say that's the square root of 1 minus 4x squared. Alright, hopefully that was that simple, and let's try one more here. The derivative of arctan of 3x. So same idea, pick your u, du, plug it into the formula that you've memorized, and pause it, check back with me in a few seconds. And again, I've got, hopefully followed my u du, there's my rule, 3 over 1 plus 9x squared. Alright, so now that we reviewed the derivatives, let's jump into the integrals. Okay, so go ahead and get these jotted in your notebook, and we do want to commit these to memory. There is no reference sheet or formula sheet. You do have to have all these memorized. So when I see the square root of a squared minus u squared, okay, that's similar to that derivative of arc sine. So its rule is going to be arc sine u over a plus c. And again, notice here's my a and my u. Hopefully you'll see this looks similar to the arctan derivative, du over 1 plus u squared. Very similar. Instead of a 1, we have an a. So that's going to be my arctan. And this one's just a tad different. It's 1 over a, arctan u over a plus c. The one thing they do have in common is they're both u over a. The arctan just has this extra 1 over a in front of it. So again, let's make sure we commit these to memory. Box them in, star them, do what you got to do to get those in your memory bank. So let's just go ahead and dive right in. Alright, so let's go ahead and dive into problem 1 here. The integral of 5 over the square root of 9 minus x squared. Now, I just want to stress that this is the farthest thing from my mind, this arc trig integral. I would always start with a u sub. And if that fails, that's when I'm going to get creative and think arc trig. But that's probably, like I said, the last thing on my mind. So if I were to do u sub, I would start by picking 9 minus x squared as my u. When I take its derivative, I get negative 2x dx. My du over negative 2x equals dx. Okay, so now if I go to do my sub part, if I were to replace this dx with my du over negative 2x, I think you can picture putting it there. You could easily pull out the 5 and the negative 2, but you're still left with this x, and that's not going to cancel with anything. That's how I know u sub did not work. It has failed me. Okay, so then and only then am I going to think of an arc trig integral. But again, not till I show u sub fails, because sometimes it actually works. Alright, so hopefully you're saying to yourself, okay, it kind of looks like the derivative of arc sine. The square root and the minus hopefully give it away. So my goal is to picture this integral again, and we said it's du over the square root of a squared minus u squared. All right, so I want to rewrite that integral so it looks similar to an a squared and a u squared. So I'm going to say 5 over the square root. I need some term squared minus some term squared. For the most part, this is pretty simple. Basically say to yourself, you need a 9 here. What would you square? What term squared would get you a 9? Well, hopefully you've already thought of the number 3. Same idea here. You need this to say x squared. What term would you square to get x squared? Hopefully you're thinking just x. And I'll leave my dx on here. So what this is implying is this value here is your a value, and this value here is your u value. And I want to make one more comment off to the side here. Your a value should be a constant or a number, and your u variable value should be a variable. Okay, so the a is the number, u is the variable. Okay, now because I'm using a u, I still want to make sure I do a u sub. Okay, so we're still doing u sub. In this case, we just said our u is equal to x. Therefore, your du is equal to dx, which is extremely nice. All right, I'm going to carefully substitute this back in. Hopefully you'll agree. I'm going to just take this 5 and pull it out front. So I have 5 integral. It leaves me with a 1 on top. We're going to have a squared minus u squared. And in place of dx, substituting in my u sub, and I can put in a du. Okay, so now I've got my function in terms of one variable. My only variable is u. Remember, a is a constant. And all you have to do is recognize that this is the perfect setup for our arc sine. So the the integral for arc sine is arc sine u over a plus c. So I'm going to say I have this 5 out front, so 5 arc sine. My u, we said, was x over the a value, which we said was 3, plus c. And there you have it, your first arc trig integral. Woohoo! So take your time on these. Feel free to pause it, try it again. They take a lot of practice, and we're going to do a couple more together. All right, number 2. The integral of 5 over the square root of 9 minus 4x squared dx. So again, don't think arc trig yet. Let's try a u sub. U equals 9 minus 4x squared. Du equals negative 8x dx. I get my du over negative 8x. Okay, I can easily pull the 5 and the negative 8 out front, but I'm left with this annoying x. Okay, so u sub fails. So now I get tricky and I think, okay, I see a radical and a minus sign. Hopefully you're thinking arc sine. And I always start by writing down that integral. It should see du over the square root of a squared minus u squared. That's going to help me with my arc sine. So again, I'm going to take this 5. I'm going to pull that out front. So I've got 1 over, and I want to rewrite this as some term squared minus some term squared dx. Okay, I'm making it look like this integral, a squared minus u squared. So just ask yourself, who would you square in order to get a 9? Hopefully you've said 3. And who would you square in order to get 4x squared? Hopefully you're thinking 2x. Now this is important, this step, because this tells you your a and this tells you your u. Now don't forget to do u sub. If u is equal to 2x, that means du is equal to 2 dx. So du over 2 is equal to dx. This is who I'm substituting in to this dx. Just like a normal u sub. That part shouldn't be tricky at all. So I've got 5, the integral, 1 over square root. I've got my a squared minus u squared. And in place of that dx, I'm putting du over 2. So I'm actually going to pull out, instead of the 5, I'm going to pull out a 5 halves. integral 1 over a squared minus u squared du. Now my function that I'm integrating looks exactly like this. I've pulled out any constants that I can, and I just have to say to myself, I am staring at arc sine. So that's arc sine of u over a plus c. So I'm going to get 5 halves. Don't forget that constant out front. Arc sine. My u was 2x over the a, which was 3, plus c. And we've got it. So hopefully that one felt a little smoother. Like I said, we'll try a couple more together. And again, you just pause it, rewind it as many times as you need to, and hopefully we'll be in good shape. All right, number 3, the integral of 7 over 5 plus 9x squared dx. So again, please, please, please make sure you try u sub first. A lot of times it works. Quick derivative gets me 18x dx. Obviously that's du over 18x. I can pull out the 7 over 18, but again, I'm left with this annoying x. So u sub does fail, and we'll move on to an arc trig function then. All right, so very similar to the last one, I'm going to pull that coefficient out front, 7, 1 over something squared plus something squared dx. Now, this first term's a little tricky. See if you can come up with it on your own. What would you square to get a 5? What the heck would you square to get a 5? Can you think of it? Maybe you've got it. The only thing I can think of is the square root of 5. Then the square and the square root cancel and you get 5. What would you square to get 9x squared? Well, I would probably square 3x. Okay, so remember that step's important because this gives you your a, the number, and your u, the variable. And since we have a u, we're going to do that u sub. So my u is equal to 3x. My du is equal to 3 dx. And I get du over 3. And I'm going to substitute that into my dx. So I've got 7 integral 1 over a squared plus u squared, and I've got du over 3. So in front of my integral, I'm going to pull out 7/3. 1 over a squared plus u squared du. And it's not arc sine this time because I don't have the minus and the square root. This is the arctan. And again, you're just going to have to commit those formulas to memory. Arctan is 1 over a, arctan u over a plus c. So when I substitute these in, I'm going to get 1 over, my a was radical 5, arctan u over a, my u was 3x over radical 5. I've got a plus c, and don't forget you had that 7/3 out front, so I'm going to multiply this beginning part by 7/3. So my final cleanup then is going to be 7 over 3 radical 5, arctan 3x over radical 5 plus c. Now some of you might be wondering whether you have to use the conjugate or rationalize this denominator here. The only time I would do that if I don't see my answer in a multiple choice. Remember, you do not have to simplify in our AP Calc exam. All right, number 4, the integral of 12 over 1 plus 9x squared. So I think you can do the u sub in your head by now. If this is your u, its derivative should be 18x, and the x obviously doesn't cancel, so it fails. So go ahead and try this one on your own, pause it. I'm just going to work out the steps in a few minutes and see if you get the same thing. But don't cheat yourself, pause it, try it on your own. All right, so here's my work. I tried to rewrite these as 1 term squared and 1 term squared. I move that constant of 12 out front. So that's my a and that's my u. I clearly did some u sub off to the side, so I replaced my dx with du over 3. So here I am rewriting it. I pull the 12/3 out as a 4, and I've got my a squared plus u squared. which is equivalent to arctan. My 1 over 1, and then times this 4 gets me a 4 there. Arctan u over a plus c. All right, number 5, e to the x over 16 plus e to the 2x dx. So again, I'm going to do the u sub, and I'm going to try it in my head. Obviously, my denominator would be my u. Its derivative would be e to the 2x times 2. And clearly, e to the 2x wouldn't cancel with e to the x, so it doesn't work. All right, so I'm going to try to write it as 2 terms squared on the bottom. Now, I can't pull this e to the x out on top because it has a variable. It's not a constant. So I'm going to say this is e to the x over, I need some term squared plus some term squared. All right, so I think the 16 should be obvious. What are you squaring to get 16? Of course, you're going to say 4. Now, be careful with this guy. This e to the 2x here. What would you square to get e to the 2x? Think about it. What would you square to get e to the 2x? Hopefully you're thinking e to the x. And if I haven't sold you on that, think about the power to a power rule. What would you do with those exponents? Again, multiply. So x times 2 would be 2x. So when I square e to the x, I get e to the 2x, not e to the x squared. You multiply these exponents. So this is telling me that this is my a, and this is my u. So off to the side, I'm going to do a u sub. So my u is equal to e to the x. Therefore, my du is also equal to e to the x dx. So I've got du over e to the x equals dx. And this is what I'll substitute into my dx. So I've got e to the x over a squared plus u squared. And then I've got du over e to the x. These e to the x's should nicely cancel. And I'm left with 1 over a squared plus u squared. So hopefully that screams out to you arctan. Again, there's no radical, there's no minus sign. The plus sign is your arctan. And the integral you should have memorized is 1 over a arctan u over a plus c. So my 1 over a is going to turn out to be 1/4 arctan. Now again, feel free to write that as tan inverse. They mean the same thing. U over a, so e to the x over 4 plus c. And there you've got your final answer. All right, number 6. This time, it's a definite integral. We have bounds. So we're going to do the same thing, but in the end, we're going to have to plug those bounds in very carefully. All right, so I'm going to try u sub in my head again. 4 minus x squared gives me 2x. The x's obviously won't cancel. U sub fails. So I'm going to rewrite this as something squared and something squared. And again, hopefully you're saying to yourself, 2 squared is 4, minus the quantity x squared would get me x squared. All right, the whole point is that's telling me my a, that's telling me my u. I'm going to leave that as 0 and 1 for now. I'm going to keep going, do a simple u sub. If u is equal to x, du is equal to dx. So I can substitute in my du right away. So this is a pretty nice u sub. So I've got my du over the square root a squared minus u squared. And I know it's u sub and I'm using u, but I'm going to keep the bounds 1 and 0 on for the moment, even though those do not go with u. I did not change my bounds at the moment. I'm going to say this is the integral of arc sine u over a, so that's x over 2. And don't put the plus c on because we have bounds. Now, since I substitute the original one back in, I'm going to use my original bounds. So I'm going to say that's arc sine of 1/2 minus arc sine of 0. All right, now you can't actually leave it like this. These are two values you have to know. You've got to be able to simplify this. And arc is kind of like the answer. Think backwards. If I tell you the answer is 1/2 and I'm talking about sine, what's the angle I'm talking about? You know, give me a 30, 60, 45. The sine of who is 1/2? Well, hopefully you're thinking 30, which is pi over 6, minus. The answer is 0, and I'm talking about the sine function. Who do you take the sine of to get 0? Hopefully you're thinking 0. So this final answer is going to get me pi over 6. All right, we made it to the last problem of the night. One more definite integral. So take your time. Again, I'm trying U sub. It doesn't work. Hopefully you've done it in your head by now. This one should look familiar anyways. So I'm going to rewrite as 2 terms squared on the bottom. So hopefully you're getting ahead of me and can figure out what those 2 terms are. Obviously this is 1 squared would get me 1. And we just talked about this, maybe 2 previous problems. That would be e to the x. And again, that power to a power gets me the 2x. All right. The whole point, this tells me my a, this tells me my u. Oh, Bailey. So now that I know my a and my u, I need to do a simple u sub. U is equal to e to the x. Du then is also equal to e to the x dx. And I've got my du over e to the x. That is what I will substitute in here. So I've got my e to the x over a squared plus u squared, and this is my du over e to the x. Those cancel. That gets me my arctan. Remember, it's 1 over a, so that's 1 over 1 is just 1 out front. Arctan u over a, e to the x over 1 is just e to the x. And don't put a plus c on this time. We had those bounds, which I believe were 0 to the ln of 2. Now again, I didn't change my bounds because I plugged the original back in. These bounds go with the letter x, and I put the x back in. Oops, and if I keep going here, I'm going to get arctan of e to the ln of 2 minus arctan of e to the 0. Okay, now be real careful with this. We're not done quite yet. Right here, I want to talk about that zap rule. E and ln zap each other out. They don't disappear. They just zap each other out, so I'm really just left with the number 2. So I have arctan of 2. Do you have any idea who to take the tangent of to get 2 as an answer? Well, I don't. You know, if it was radical 3 over 3 or radical 3 or 1, I would know an answer, but here I don't, so I'm just going to leave it as arctan of 2 minus e to the 0. Anything to the 0 is actually 1. Who do you take the tangent of to get 1 as an answer? Well, hopefully you know that's pi over 4. So my final answer is going to be arctan of 2 minus pi over 4. So hopefully we've done enough examples where you're feeling pretty decent with it. Again, if you're not, you're in control. Pause it, rewind it, go back and play it again. Have a great night.